Okay, Unit 6, Day 4. Today we're going to talk about graphing tangent functions. And like all the other functions, the input is an angle. That's the independent variable. Once that is chosen, the value of that angle is determined, and so that depends on the angle. If we look at the terminal ray of tangent, we can see that it goes from 0, 0 to this point, which is over x and up y. Well, the change in y over the change in x, that's slope. And so rise over run, or y over x, or opposite over adjacent, they all represent tangent. When are slopes positive? Well, if I go into the first quadrant, x is positive and y is positive. If I go into the third quadrant, y is negative and x is negative, but the ratio is still positive. So in quadrants 1 and 3, the slopes are positive. In quadrant 2, x is negative, y is positive. In quadrant 4, y is negative, x is positive. When 1 is positive and 1 is negative, and it's y over x, it's a negative fraction, and so in quadrants 2 and 4, the slopes are negative. Well, a slope, if we say it's y over x, it's 0 when the top of the fraction is 0, and y is 0 here and here. So it could be 0, pi, 2 pi, over and over and over, or we could say k pi, where k is an integer. When are slopes 1? When x and y are the same. 1, 1, and negative 1, negative 1. This is 45 degrees, or pi over 4. This rotation is 45 degrees in the third quadrant, which is 4 pi over 4 plus 1 more pi over 4 is 5 pi over 4. And if I keep going every pi, or every 4 pi over 4, I'll get 9 pi over 4, etc. So I could say it's the first pi over 4, and then pi, 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 a bunch of pi's, where k is an integer. A slope is, for pi over 2, well, that's here, and 3 pi over 2, or negative pi over 2, that's here, and 3 pi over 2, that's here. Well, in both of those cases, the y value is either 1 or negative 1, but the x value is 0. And when 0 is on the bottom, it is undefined. As theta is approaching pi over 2 from the left, well, here's pi over 2 from the left. That's where the angle is getting bigger. And as the angle is getting bigger, the slope is getting steeper and steeper, and it's going to infinity. If I approach theta, or negative pi over 2, from the right, that means I'm going from 0 to negative pi over 2. That's this way. The lines are getting steeper and steeper and steeper, but they're negative slope. They're going down. So that's negative infinity. As I approach pi over 2 from the right, the positive end, pi over 2 from the right, that means I'm going from pi to pi over 2. That's this way. And the lines are getting steeper and steeper and steeper, but the slope is negative. Let me correct that. Let's do that again. If I'm going to pi over 2 from the right, that's pi over 2 from the right, that's this way. Is that right? So I'm going from pi to pi over 2, so that's getting steeper and steeper and steeper, but more negative. So that's negative infinity, steeper but negative. And then if I approach 3 pi over 2 from the left, that means I'm going from the left pi to 3 pi over 2 this way. The lines are getting steeper and steeper and steeper, but they're in a positive orientation, so I need to correct my notes. This should be positive infinity. So remembering that tangent is slope, or y over x, at negative pi over 2, that point is 0, negative 1. And if I have y over x, 0 in the denominator, that's undefined. Well, negative 12 pi over 24 would be negative pi over 2, which would be the same place, but I'm coming in a bit, and I'm thinking it's going to be the same as this one, but negative. And so that's negative, actually, 15.26. Let me start over so that I won't be as confused. Let's start here. If the angle is 0, we're here, and this is the point 1, 0. That's a fraction of 0 over 1, and that's 0. I'm going to jump for a second to pi over 4. That's a one that's 45 degrees and perfect, and that slope is 1. Pi over 6 is like 30 degrees. Let's say that's about there, and that's the 0.58. And then half of that is pi over 12, and let's say it's the 0.27. Again, we don't have to be too exact here, just to get a sense of what's going on. As I grow up, 1.73, up further, 3.73, up further, 7.6. Now if I go in the other direction, I should get the same things but negative. And so hopefully you can see that. And so I think what I'm going to do is to go back and just redraw that as what I had earlier, negative 7.6. Same thing going this way, but going this way and negative. If I plot those, we see that at pi over 2, we have undefined, which back in the day was a vertical asymptote, and negative pi over 2 was undefined, another vertical asymptote. At 0, we have this point. Now let's just graph two other points to get a sense here. Negative pi over 4 is negative 1, and pi over 4 is 1. Asymptote, point, 0, point, asymptote. These other points will fit along the line, but these, I think, are the key ones. Make life easy for ourselves. So here, we're going to just sketch our parent function that we just did, so that at negative pi over 2 and pi over 2 we have vertical asymptotes. We have an intercept at 0, 0. At 45 degrees, or pi over 4, tangent is 1. At negative 45 degrees, or negative pi over 4, tangent is negative 1. And here's our parent graph. And it just keeps going the same way, middle, 1, negative 1. So we still have 5 things, 3 points and 2 asymptotes. Just like for sine and cosine, we have 5 bits of information. So the domain is everywhere where I don't have a vertical asymptote. So we can say that it can't be pi over 2, let's say this one. And then do you notice that each one after that is pi away? So plus pi k, k again is an integer. The range, forever up and forever down. Here, this graph starts over again here and over again here. These periods are pi apart. Pi apart. There's your period, and you can see I drew 3 of them. The y-intercepts, the x-intercepts are here, here, and here, at 0, pi, and 2 pi, so multiples of pi, where the multiple has to be an integer. The vertical asymptotes are where the domain can't be, so this should look familiar to you. It's x equals pi over 2, let's say the first one, and then each one after that is pi away from the first one. And you can pick any one you want for the first one. I just happen to pick pi over 2. Again, k is an integer, multiples of pi. The midline, y equals 0. Some things don't change. Now, we could say that it's increasing, but from here to here, it's not increasing. It dropped again. So it's increasing during each period, but the graph is not increasing steadily from beginning to end, just within each period.